Hello everyone, in this lesson we will discuss the continuity of a function. We'll explain the three conditions for continuity at a point. We'll define continuity in an interval, say the theorem for the limit composition of composite functions. Should be composite functions. And describe the three types of discontinuities and then provide an example of the intermediate value theorem. It's IVT. Intermediate value theorem. Okay, first of all, let us look at the conditions for continuity. Continuity definition. Let f be a function defined on an interval containing all values of x close to a. Then f is continuous at a if the limit as x tends to a of f of x is equal to f of a. In other words, f of a must exist and have a value. The limit as x approaches a of f of x must exist. And thirdly, they must be equal. So let's look at a continuity checklist for a function f of x determined on an open interval around a. Number one, is f of a defined? Number two, does the limit as x approach a of f of x exist? Number three, is f of a equal to the limit as x approaches a of f of x? If the answer to all three is yes, then f is continuous at a. If the answer to at least one of these is no, then we say that f is discontinuous or has a discontinuity at a. Let's look at the type of discontinuities that may exist. The three basic types of discontinuities that may exist are removable discontinuity, that is where the function has a whole function value, it has a whole, where the graph would be at a. Then there's a jump discontinuity where the graph goes up to a point and then jumps up or probably down, like it's gapping up or down. If there's a gap between, then it's called a jump discontinuity. And then infinite discontinuity is when we have a vertical asymptote. Infinite discontinuity, and it can be from either side. Infinite, as long as it's going to infinity, then that's called an infinite discontinuity. As long as the function value is going to infinity, positive or negative infinity. There are other discontinuities such as oscillating discontinuity. That means the function is just going up and down. It's going nowhere, just oscillating between bounds. And that's the difference between infinite and oscillating. In oscillating, it's just staying within a bounded area. And infinite is where it's just going off to infinity. Okay, let's look at an example. The graph of f of x is shown. Determine if f of x is continuous at x equals -2, at x equals 0, and at x equals 3. So there are three places that we are asked to look at. Use the 3-item continuity checklist to justify your answer and identify and name any discontinuities. What is the 3-item checklist? The 3-item checklist was 1. Does f of a exist, or is it defined? Does the limit as x approaches a of f of x exist? And thirdly, is f of a equals to the limit as x approaches a of f of x? Okay, so let's try to answer these questions. Let's start with looking at -2. Does the f of -2 exist? So look at x equals -2. 1, does the f of -2 exist? F of -2, does it exist? The f of -2 exists where this closed dot is, and that is equal to 2. So that checks off Item 2, does the limit as x tend to -2 of f of x exist? Is there a limit? Notice as we approach -2 from the left, your limit is equal to 2. The limit of the function is 2. And as we approach -2 from the right, the limit of the function is equal to -1. So this does not exist. The limit does not exist because the limit as we approach from the left is different from the limit as we approach -2 from the right. Once this happens, once you find any one of these not checking off, then at this point we can say that the graph, right, or the function is not continuous at x equals -2, right? So it has a discontinuity. What type of discontinuity does it have? So the discontinuity type is a jump discontinuity. That's a jump discontinuity. Jump discontinuity. Okay? Jump discontinuity. Because it has a gap. It's a gap. Gaps right there. Gaps down. Okay, let's look at x equals 0. Let's look at x equals 0. At x equals 0, does f of 0 exist? F of 0 equals 1. Next check. So that checks off. Limit as x tends to 0 of f of x is also equal to 1. Why? Because as we approach 1 from the right, the limit of the function is 1. As we approach 1 from the left, rather, limit is 1. Limit of the function is 1. And as we approach 0 from the right, the limit also 1. Okay, so because the limit as we approach from the left or the right side is equal to 1, therefore the limit as we approach the point is 1. Okay, so the function then is continuous. The function is continuous. Function is continuous at x equals 0. Okay. Finally, we have one more thing to look at, which is at x equals 3. At x equals 3, f of 3 equals 0. Okay? F of 3 is equal to 0. No, that's wrong. Look for the closed dot. F of 3 is equal to -1. F of 3 is equal to -1. And the limit now, this is what is 0. Limit as x tends to or approaches 3 of f of x is equal to 0. That is what is correct. Okay. So it is not continuous. It's not continuous because here's what happened. F of 3 is not equal to the limit as x tends to 3 of f of x, right? Not continuous because -1 is not equal to 0. So -1 is not equal to 0. Okay? What kind of discontinuity is there? We got to say that the kind of discontinuity that is here is called a removable removable discontinuity. So it has removable discontinuity, just this for short, at x equals 3. Okay, well, that's how we do the evaluation. Sometimes you may be given a function written out to find whether or not the function is continuous. Okay, so number 2, consider the function f of x is equal to x plus 2 if x is less than 1, and 3 minus x squared if x is greater than 0 to 1, is greater than equal to 1, sorry. Is f continuous at x equals 1? Use a 3-item checklist. So 3-item checklist again at x equals 1. Let's do it. F of 1 be equal to, when x equals 1, we're going to use this. So we're going to use this second equation or sub-equation for f of 1. So f of 1 will be equal to 3 minus 1 squared. So 3 minus 1, which is equal to 2. Second check is your limit as x approaches 1 of f of x. Now you have to look at two things. What is the limit as x approaches 1 from the left and from the right? So limit as x approaches 1 from the left, then we will use of f of x. It's going to be the limit as x approaches 1 of the first function, x plus 2, that will be equal to 1 plus 2 equals 3. And then let's do the limit as x approaches 1 from the right. F of x is going to be limit as x approaches 1 of your other function, which is 3 minus 1 squared, 3 minus 1 squared. We already did that and found that it was equal to 2. So is 3 the same as 2? No, so this is not continuous. Or some people shorten this to say that's CTS for continuous, because 2 is not equal to 3, right? Because f of 1 is not equal to the limit x tend to 1 of f of x. Okay, what kind of discontinuity is this? It has a jump discontinuity, right? A jump discontinuity. And that's about all that we be able to do for today. Thank you all for watching. Please remember to like and subscribe, and see you in class.